Potential benefits of AI for society and social good. If we can navigate the smart technology era wisely, AI has tremendous potential benefits for social good and society as a whole. This also ties in with the sentiments of Max Tegmark, president of the Future of Life Institute, who said, "Everything we love about civilization is a product of intelligence. So amplifying our human intelligence with artificial intelligence has the potential of helping civilization flourish like never before, as long as we manage to keep the technology beneficial." AI's benefits for society also dovetails with the benefits expected from the broader Fourth Industrial Revolution or smart technology era, which centers around a future for humanity where as many people as possible enjoy more freedom, better health, higher levels of education, and more opportunities to live the lives they value while suffering less from insecurity and economic uncertainty. The latter is the words from Klaus Schwab, founder of the World Economic Forum and author of the Fourth Industrial Revolution and Shaping the Fourth Industrial Revolution, where he also makes the following call that speaks further to the societal benefits of the smart technology era. The new technology age, if shaped in a responsive and responsible way, could catalyze a new cultural renaissance that will enable us to feel part of something much larger than ourselves, a true global civilization. The Fourth Industrial Revolution has the potential to robotize humanity and thus compromise our traditional sources of meaning, work, community, family, identity. Or we can use the Fourth Industrial Revolution to lift humanity into a new collective and moral consciousness based on a shared sense of destiny. It is incumbent on us all to make sure that the latter is what happens. In a recent survey report by the Pew Research Center called Artificial Intelligence and the Future of Humans, where they have interviewed almost 1,000 technology experts, entrepreneurs, developers, researchers, activists, as well as business and policy leaders, they outlined some of the benefits and positive outcomes of how humans and AI might evolve together in the next decade. This includes new life and work efficiencies, where we can extrapolate from what we already observe in terms of how AI is being integrated into many facets of life to enhance human capacities, productivity, and create new efficiencies, as well as augmenting and optimizing the life and work experiences of humans. By continual offloading routine and tedious intellectual and physical tasks to AI and robotic systems, these smart systems can not only relieve us from repetitive or physically dangerous or difficult tasks, but also open new challenges for our activities and allow us to embark on more creative, meaningful, intellectual, and strategic pursuits that might have a long-term and in-depth nature. As AI becomes more naturally integrated into our everyday lives and developing a better understanding of our daily routines with better human-machine interfaces, wearable devices, internet access, and sophistication, we can also expect it to further enhance our ability to communicate and learn, improve our communication opportunities and sharing capabilities, help us to create better habits, increase the amount of time we devote to activities we find meaningful, and assist us in living full, healthy, productive, and purposeful lives. From a work experience perspective, augmented intelligence and cognitive analytics will assist us with basic decisions, freeing up the human intellect to find avenues to accelerate growth and allow us to drive transformation at a faster pace. We are also likely to see the emergence of a higher level type of labor supported by AI-driven augmented intelligence that requires creativity, direction, and supervision of the safe investigation and execution of business initiatives, along with perseverance and grit to accomplish the defined goals and objectives. In augmenting and complementing human capabilities, such as cognition and decision-making, AI-driven effective computing and productivity-increasing adaptive human-machine interfaces can also protect us from irrational behavior and stupidity, challenge our decisions with insightful questions, and provide continuous support, advice, and communications. AI-driven intellectual companions with interactive reasoning and context understanding can also help manage information overload, enhance search, summarize, and engage on information content and make recommendations. We have also seen the beneficial use of AI in research across many fields of study, such as medicine, neuroscience, material science, biotechnology, astrophysics, engineering, and agriculture. As AI models in specific domains have also proven to produce more accurate results compared to human experts, we can expect more of these models to be embedded in real-world applications, such as, say, medical diagnostics. The promise of AI is to scale appropriately customized advice to as many people as possible in most, if not all, fields of human endeavor, and to find new solutions to persistent problems and improve the overall quality of life. AI can also help create new economic activities and services or transform existing ones into becoming cost-effective and abundantly available. Apart from enriched interactions between humans and AI systems, freeing up time for socializing with other humans, AI will also enhance human-to-human interaction and assist, augment, and amplify individual and collective human intelligence in a substantial manner. It can also function as an interpreter of communication to help us be comparably understanding to others, improve the way we relate to one another, and further greater societal progression. AI, as also a prerequisite to achieving a post-scarcity world, has the potential to enrich the quality of life so that the current age of labor and workalism will transition into a society where its well-being will, for example, be enhanced through intellectual pursuits, sustainable development activities, culture, leisure, the arts, and entertainment. Furthermore, AI can support the slow movement that advises a cultural shift towards slowing down life's pace and focusing more on quality, doing things as well as possible as opposed to as fast as possible, and connecting with people and the natural world. Societies, individuals, businesses, organizations, and governments will need to be thoughtful about how AI systems are implemented and make sensible choices on use and restriction of use that benefit as many people as possible. To maximize AI's benefit for society, AI systems that administer social and governmental organizations need to ensure equity, empathy, and consistency in provisioning of services to the population, ensure ethics training to make good decisions, disseminate equitable responses to basic care and data collection, reduce knowledge overload as it implements policies and serve the public good, remove human emotion-driven discrimination, and avoid exploitation. As AI systems are being integrated into human societies, we can expect most aspects of human existence to be affected. There are also parallels between the potential benefits of AI and that of electricity for society. The impact and utility of AI in the future will most likely be similar to that of electricity with respect to characteristics such as its pervasiveness, integratedness, and functional visibility. As with electricity, AI systems are not always functionally visible to us unless it is not working. We will likely encounter AI in behind-the-scenes systems built to adapt homes, living spaces, workspaces, and smart community and city environments to better suit our needs and desires. Similar to electricity, it might operate in a smart grid-like system where there is an AI supervisor system that coordinates a network of other AI systems. With smart instrumentation, these AI systems can be fed by inputs such as environmental sensors, air quality, sound, images, video, and information about natural and social events to provide collective notifications and insight to everyone in a certain location about the concerns of environmental factors, social dynamics, physical health, crime through community policing, and pre-crime security monitoring of airports and other public assembly places. Given AI's transformative impact across all industries and sectors, as we have seen in the previous chapters, large portions of the world's population are already being affected. We also see this impact as AI is being applied to help public transportation systems in providing better services to citizens by optimizing routes, travel times, and stops, as well as enabling significant improvements to traffic, sewage treatment, supply chains, utilities, agriculture, and food distribution transportation. AI will likely play a critical role in dealing with the increasing complexity and demand of large-scale technology systems such as the internet, power grids, highways, and roads. There are also great expectations that AI solutions will be able to make an impact in developing countries and the poorest parts of the world by helping with the delivery of cost-effective health and education services, as well as solving issues of water production, food growth, and distribution. AI and effective computing should also benefit the elderly and physically handicapped people of society, with an ever-growing array of options and choices pertaining to support, health, disposition, and mobility. As AI is also similar to other labor-saving devices, AI is also correlated with increased health and lifespan and will keep a population healthier and safer in a highly instrumented world. AI will also assist us in reducing man-made and natural risks such as terror activities, environmental threats, and nascent diseases, epidemics, and pandemics. With regards to the future of work, it is clear that new work will materialize and that there will be some solutions to address job loss, but the latter is still a major concern that we will address later in this chapter. The other two major AI benefits for society described in the Pew Research report are with respect to education and healthcare, which we also covered extensively from an AI use case perspective in the previous chapter. Many people have high aspirations and hopes as the application of AI progresses to create meaningful, adaptive, and personalized learning assistants that can accelerate and scale targeted lifelong and life-wide education for as many people as possible around the globe. Due to smart technology adoption, agility, and speed of execution, the non-traditional and informal education sector is likely to grow much faster than the established formal education sector. Due to massive demand, adult education will be transformed to cater for relevant 21st century skills, knowledge, and occupational training to help ensure people are better equipped and adaptable to function more optimally in the smart technology era. AI, along with other smart technologies such as augmented and virtual reality, will enable new learning models that emphasize connection, assimilation, and accommodation of knowledge as opposed to just retention or regurgitation of knowledge. It fits in with training people to learn and reason from first principles and understand concepts, ideas, and relations in a deep way. As discussed in the previous chapter, personalized learning assistants that are always available anywhere, along with adaptive learning management systems, will make it possible to easily adapt to an individual's learning style and speed, as well as day-to-day cognitive and emotional state to drive learning forward in a real-time and responsive fashion and give people insight and guidance into their personalized learning journey. AI's applications in healthcare are also seen as one of the key areas of societal benefit, where we can expect that going forward, many lives can be saved, improved, and also extended with robust AI-driven personalized diagnostics, healthcare delivery, precision medicine, and wellness solutions. With smart technology tools, wearable devices, sensors, and intelligent virtual assistants becoming increasingly accessible at greater scale to society, more people can benefit from preliminary screening and diagnostics, quicker recognition of risks, early identification of diseases, lessening of medical errors, recommended preventative actions, and expert guidance. These smart technology health-related solutions will become a conduit for incorporating the most up-to-date advances in medical treatment based on best practices and state-of-the-art healthcare research and have this available to more people, including healthcare professionals. The development of drugs will also be accelerated through the use of AI. Furthermore, personalized AI-powered healthcare services and solutions will become a more tangible and impactful reality to society with greater access to health-related data such as medical history, health risk assessments, genetic makeup, DNA profile, drug allergies, medical claims, and real-time data from fitness and health-related wearable devices and intelligent virtual assistants. These smart digitized healthcare solutions will also allow for more frequent and quicker identification of the benefits, risks, and effectiveness of medical treatments and drug interactions on a personalized level, as well as minimizing overdiagnosis and overtreatment scenarios where human bias and emotions might be counterproductive in the decision-making process. Continuous real-time monitoring of people's health, especially high-risk patients, is a reality via internet-connected medical devices and wearables that provides a constant stream of data. It would be a substantial benefit to society to have these types of solutions available in cost-effective and scalable fashion to most of humanity. In particular, those people that are completely underserved in rural and poor communities, as well as the elderly and people with disabilities. That said, for both healthcare and education application areas, there are also concerns about data privacy and the digital divide, but this can be addressed on another level by, for example, implementing policies, regulations, and democratizing of AI and its solutions, which I will discuss in later chapters. Stanford University produced a periodic expert review report called the 100-Year Study on Artificial Intelligence a few years ago that provided some reflections about AI and its anticipated influences over the next decade or so. This is being followed up by studies exploring the application of AI in healthcare and personal advice, as well as AI-driven advisory systems in preparation for the next report. They emphasize the significantly growing future AI use cases with a profound beneficial impact on society and the economy, such as healthcare diagnostics and targeted treatments, physical assistance for elder care, as well as self-driving cars. The report also stresses the importance of innovative mechanisms to help ensure that these benefits are shared as broadly as possible across society and that democratic values such as transparency, equality, and freedom are not compromised. They also make the point that AI in the longer term may potentially be considered as an innovative and radical vehicle to create wealth that can be shared by everyone. Just by extrapolating from our current interaction and uses with smartphones and the wide spectrum of interconnected devices that generate sensor information at scale, along with the current development path of AI technology and its applications, it is clear that the future relationship that people have with these smart devices will become more subtle, adaptable, and individualized. There is a shift towards developing smart systems that are more human-centric, trustworthy, and increasingly better at interacting and collaborating with people, as well as more effective and scalable in the methods to train these AI-driven systems. Given the progress that we already see with autonomous transportation, in particular self-driving vehicles, it is likely that this form of embodied AI system will have a substantial influence on how people perceive the manifestation of AI in our everyday lives. This will likely have a chain reaction effect on how people use their time, where they live, how shared transportation is personalized, and how cities and metropolitan areas are organized and designed. With significant improvements in robotics, mechanical systems, and AI to ensure safe and more dependable systems, we are also likely to see an increase in the long-awaited use of home and service robots in application areas such as cleaning, package delivery, and improved security. By having home environments better integrated and connected with health monitoring systems and devices, the door will be opened for some more innovation and beneficial health-related applications that might include individualized rehabilitation and in-home treatments and therapy. This report also emphasizes the broader positive societal consequences of AI-driven education, in particular online education that uses AI for personalized learning, which are set to likely become part of a blended classroom type of educational experience and embedded at all levels of education. Although AI-driven entertainment will enable a greater variety of entertainment forms that are more individualized, customized, engaging, and interactive, more work needs to be done to determine how entertainment should be shaped to be in the best interest of the individual and society. Similarly, The democratizing of AI-generated media or AI-assisted entertainment content creation should in principle be a good thing for society, but the effects of this on society and how humans' taste for entertainment will evolve is also uncertain. As we contemplate this, we should measure the success of AI applications to the value that they create for society. Another major beneficial application of AI for society is in the area of public safety and security, which can include a range of application areas such as cybersecurity, credit card fraud detection and prevention, preventative and predictive policing with anomaly detection of possible crimes and removing human bias in decision making, and unjustifiable targeting of people. Stanford University has also recently launched the Institute for Human-Centered Artificial Intelligence that focuses on guiding artificial intelligence to benefit humanity through their mission of advancing AI research, education, policy, and practice to improve the human condition. The Organization for Economic Cooperation and Development, OECD, has recently reported on how AI is used to detect, respond, and recover from the COVID-19 coronavirus pandemic. This is another example of how smart technology, along with all relevant data, can be utilized for societal benefit and help to understand the virus, fast-track research and development of relevant drugs and treatments, recognize and diagnose the virus, for example, pattern recognition using symptom data and medical imagery, predict its growth and evolution, for example, epidemiological models, and predicting an individual's likelihood of infection, help with stopping or at least slowing down its spread through the use of contact tracing and surveillance, provide early warning and interactive response through relevant contextualized information through the use of intelligent virtual assistants and chatbots, and filtered news to combat misinformation, and smart monitoring of the recovery, for example, tracking economic recovery through the use of social media, GPS, and satellite data. Whereas in the past, it was mainly increases in capital investment and labor that helped to drive economic growth across the globe. These productivity levers are not able to sustain these growth levels anymore, as can be seen in the steady decline in the average gross domestic product growth rate over the last 3 decades. Not only has the labor force growth in developed countries been stationary, but the growth rate in the total factor productivity, which measures how well an economy uses its existing capital and people, has been slowing for the last decade. AI has the potential to overcome the physical limitations of these traditional drivers of production by not only generating substantial increases in productivity and efficiency, but also transform the way growth is created. In an Accenture report called Why Artificial Intelligence is the Future of Growth, they have modeled the expected economic growth with and without AI for 12 countries that produce more than 50% of the world's economic output. Besides the USA and Japan, the rest are from Europe. From this analysis, the USA's annual growth rate could jump from 2.6% to 4.6% in 2035, which implies an additional $8.3 trillion added to their economy, whereas Japan can triple their real gross value added and the European countries can double theirs on average over this period. The report shows how AI can both enhance the total factor productivity and add additional growth as a new factor of production. This can be done through 3 channels, where the first is a new virtual workforce, which Accenture calls intelligent automation, that automates physical tasks in, for example, factories and warehouses with the use of robots or the automation of certain customer services through the use of chatbots and self-learning intelligent virtual assistants. The second AI-induced growth channel is augmented labor and capital by complementing human capabilities, helping people to focus on performing tasks where they can excel and add the most value, and also enhance capital efficiency through process and equipment optimization, predictive maintenance, and reducing downtime. The third growth channel is innovation diffusion and focuses on how AI-induced innovation spreads through the economy, with self-driving cars providing a good example of how its impact could over time extend well beyond the automotive industry. It can, for example, also affect how people spend their time, which opens leisure, entertainment, and retail opportunities. How insurance could create additional revenue streams with better instrumentation and data available with regards to driving and total customer mobility, and how public health is positively impacted through a reduction in traffic and road accidents and fatalities, as well as people with disabilities being able to move around more freely. Amongst the vast array of social good projects where AI can make a tremendous impact and affect hundreds of millions, if not billions of people, there are some big-ticket ones such as climate change and curing cancer, but also many others that address very challenging social problems without the need to necessarily make scientific breakthroughs. McKinsey Global's Institute report on applying AI for social good provides a mapping of AI use cases to domains for social good and discusses how AI solutions can be used for social benefit, as well as how risks can be managed and obstructions can be overcome. The broad spectrum of AI capabilities are applicable to social good use cases and includes, for example, image and video classification, object detection and localization, face detection and person identification, tracking, natural language processing and understanding to address language and communication hurdles, sound detection and recognition, sentiment analysis, emotion recognition, content generation, and reinforcement learning. The 160 social good use cases analyzed covers all 17 of the United Nations Sustainable Development Goals and map to domains such as health, for example, treatment delivery, prediction and prevention, long-term care and mental wellness, and hunger. Education, for example, education and completion of education, maximizing student achievement, and teacher and administration productivity. Security and justice, for example, harm prevention, fair prosecution and policing, and equality and inclusion, for example, accessibility and disabilities, exploitation and marginalized communities. On the health front, most of the use cases focused on early stage medical diagnosis, such as detecting skin cancer through image recognition and detecting potential early signs of diabetes with an 85% accuracy through AI-enabled wearables that capture heart rate sensor data. AI can help to address hunger and famine by optimizing food distribution networks in regions that face shortages. On the education front, impactful use cases involve the effective distribution of online education services to underserved populations, early learner distress identification, and the application of adaptive learning through customizing content recommendation based on learners' abilities. Other social use case domains that are also especially relevant for the current times are crisis response, for example, disease outbreak, migration crises, natural and man-made disasters, and search and rescue. Information verification and validation, for example, false news and polarization. Environment, for example, climate change and adaptation. Energy efficiency and sustainability, and conservation of animals, plants, land, air, and water. And economic empowerment, for example, financial inclusion, initiatives for economic growth, labor supply and demand matching, and agricultural quality and yield. AI can help to predict virus and disease transmission patterns through applying machine learning on a spectrum of data sources such as telecommunication data, geospatial data, online search data, social media data, and vaccination data. There are also many environmental use cases such as using AI-powered image recognition and robotics to sort recyclable material from waste, predict routes and behavior of illegal fishing boats using satellite imagery, and detecting illegal logging in exposed forests through AI analysis of audio sensor data. Other social use case domains from a governmental perspective includes public and social sector, for example, services to citizens, effective management of public and social sectors, public finance management and fundraising, and infrastructure, for example, energy, water and waste management, transportation, real estate, and urban planning. I will discuss some of these AI-driven public sector use cases later in this chapter. Most of the technology giants also support AI for social good initiatives to varying degrees. For example, Google has applied AI to applications such as predicting famine, protecting whales, and forecasting floods via their own AI research and engineering projects, and has also launched the Google AI Impact Challenge, which was a call for organizations around the globe to submit ideas for how AI can be used to help address societal challenges. They received more than 2,600 applications from not-for-profit organizations and for-profit social enterprises in 6 continents and 119 countries, with projects addressing a wide range of issue areas such as crisis response, economic empowerment, education, environment, equality and inclusion, health, and the public sector. A crisis response project example involved the prediction of wildfires, earthquakes, floods, and other catastrophic events by applying deep learning, image classification, and object detection to data sources such as historical occurrences, emergency response organization internal data, public, international, and regional data, satellite images, and weather data. Some economic empowerment use cases involve improving access to credit for financially excluded individuals and communities by applying deep learning and other machine learning analytics to external transaction data such as utility payments and mobile phone usage, historical borrower repayment rates, and financial organization internal transaction data. Some agricultural use cases involve forecasting, identifying, and managing crop damage, conserving and measuring soil health, and obtaining estimates for irrigation, fertilizer, and pesticide usage. These applications apply deep learning and other machine learning techniques, image classification, and object detection to sensor and weather data, as well as image data from mobile applications that take pictures of crops. One of the educational projects involved creating learning tools and emotional training for learners with autism spectrum disorder, where facial recognition and speech processing are applied to faces and poses in images and videos, as well as other user-generated data via mobile applications. Another involved mapping out school locations in developing regions with the use of image classification, object detection, and natural language processing on a variety of data sources such as census data, satellite images, national and regional poverty, employment, and health outcomes related data, as well as publicly available articles and news about specific schools and data from United Nations Statistics Division. A project to enhance teacher and administration productivity involved the use of deep learning, natural language processing, and machine learning analytics to provide grading and feedback to improve skills by using past graded papers, projects, and homework as training input. Some key environment projects involved estimating air pollution as well as its causal effects, such as health outcomes or severe storms. For the latter, deep learning and other machine learning techniques were applied to insurance claims data, weather and storm data, publicly available community demographic data, as well as emissions data. To estimate urban air pollution and tracking of concentrated methane emissions, a combination of deep learning, image classification, and object detection were used on air sensor data, hyperspectral imaging, satellite images, traffic flow data, and publicly available emissions data. To identify and monitor plastic debris on water and land, image classification and object detection was applied to existing street images from Google Earth's Street View, satellite images, and user-generated pictures and videos through mobile applications. On the quality and inclusion front, projects varied from accessibility and disabilities, migrants and refugees, human exploitation, and fair analysis in criminal proceedings. For example, predicting human trafficking patterns related to recruitment and transactions make use of a variety of structured and unstructured data, such as arrest and indictment records, federal, state, and local human trafficking cases, police narratives, and publicly available U.S. Department of Labor enforcement data. To forecast the demand for aid within refugee camps requires data sources such as census data, survey data, weather data, as well as datasets from the International Organization for Migration datasets for displacement tracking. The health projects cover use cases that we have already discussed before in application areas such as diagnosis, mental health, outbreaks and epidemics, prevention and treatment. A mental health project example involved triaging people at most immediate risk of suicide, where natural language processing, sentiment analysis, and speech processing is applied to SMS conversations, social media, and speech recordings. Some of the other complementary examples of AI for social good projects that explicitly map to United Nations Sustainable Development Goals include applying AI on satellite imagery and survey data to extract socioeconomic indicators and generate visualizations and predictions of poverty in areas without survey data. Predicting and addressing severe acute childhood malnutrition by applying AI to satellite images, localized food prices, and conflict data. And in the gender equality category, natural language processing methods such as topic modeling, psycholinguistic feature modeling, and audio signal processing on voice recordings and chat transcripts from crisis call hotlines for women are leveraged to escalate calls with high risk of intimate partner violence. Google also shared some insights from their Google AI Impact Challenge to help fast-track social good with AI. These include that AI is not always the right tool to use to solve the problem. Data accessibility challenges can vary significantly by sector. The demand for technical talent now also includes data and engineering expertise to complement the specialized AI expertise. There needs to be practical forward planning to help transform AI insights into real-world social impact. Most projects require partnerships to access both domain sector expertise and technical ability. As there is a significant overlap in terms of what various organizations are doing, they can benefit from shared resources and collaboration. And organizations need to be assisted in helping to prioritize responsibilities.